Today we will learn how mean, median and mode are calculated for group data as a continuous series. So here we have data that shows the fishes of varying lengths which we have collected, and we are going to find the mean of this data. So here the length is given as class intervals with a width of 5 millimeter. So you can see 5 to 10 millimeter fish of length 5 to 10 millimeter, 10 to 15 millimeter, 15 to 20, 20 to 25 and 25 to 30 millimeter. And these are the number of fish who are having lengths corresponding to these class intervals. So this is the frequency. So I have rearranged the table, or I have rewritten the table as this is the class interval. These are the class intervals, and this represents the frequency. That means the number of fish showing length of each class interval, that falls under each class interval, that shows the frequency. So how do we calculate mean? For that, we have to first find the mid value of each class, which is represented as xi. So we go to the first class interval 5 to 10. So what is the mid value? You add the lowest and the highest value of this class interval, and that will be 15. Divide it by 2. So that will be the mid value. Next one, here it will be the half of 25. You add 10 and 15, you get 25, and half the value will be the mid value. So likewise, I have found the mid value of each class, and this is the corresponding frequency. Now in the fourth column, I have multiplied the mid value of each class with the corresponding frequency, and I get xi, fi values. Now we add the xi, fy values, and we get a sum 11,500. This represents the total frequency. That means the total number of fish under study. So 680 fishes were under study who were having lengths which fall under various class intervals as represented here. So the total number of observations is 680, and the total frequency is 11,500. So how we calculate mean? Mean is equal to sigma xi, fi, that is the sum of xi, fi values divided by the total number of observations. So here 11,500 by 680 is equal to 16.91 millimeter. So this is the mean length of fishes obtained in this study. 16.91 millimeter is the mean length. So once again, we find the mid value of each class, multiply it with the corresponding frequency, take the sum of all these values, divide it by the total number of observations. We get the mean. Now we move on to the calculation of median. So the same data has been given here. So first, so here we are going to calculate median, and median represents the middle observation, the middlemost observation when we arrange them in the ascending or the descending order. So here we find the mid value. So it is already in the ascending order, we can say. So no need of a further arrangement. Now we find the mid value of each class as we did while calculating mean. Now we write the frequency corresponding to each class, and in the next column we find the cumulative frequency. That means the frequency added on one after the other. So in the first row it will be 200. Now when we move on to the second class, the frequency is 100. So we add on this frequency to the previous and we get 300. Then the next class. So taking all the observations, we get a cumulative frequency of 410, because we add 300 plus 110, we get 410. Then 410 plus 120 gives 530. Then 530 plus 150 gives 680. So that is the total number of observations because 680 fishes were studied. And what is the median? Median is the middlemost value. Since 680 is an even number, what will be the middle value? So we just go to one simple example that is if we have 10 observations. So if we number from 1 to 10, there will be two values which come in the center because 10 is an even number. And who will be those mid values? They will be 5 and 6. There will be 4 values on the top of 5 and there will be 4 values below 6. So the middle values will be 5 and 6. And 5 is 10 by 2 and 6 is 10 by 2 plus 1. So this is how we calculate the mid values for even number of observations. So since 680 is an even number, median there will be two values which come in the center. They will be 680 by 2th observation as well as 680 by 2 plus 1th observation. Just as I told you, if there are 10 observations, the 5th one and 6th one will be in the center. So if there are 680 observations, the two observations which come in the center will be 680 by 2th observation and 680 by 2 plus 1th observation. That means the 340th observation and 341st observation. So these two will come in the center. Since there are two observations which come in the center, we have to find the mean of these two. Okay, so we will just go to, so 680 by 2 is 340 and 680 by 2 plus 1 is 341. Now we go to the cumulative frequency table. All values, all the first 200 values come under this cell. 201 to 300th observation come under this. 301 to 410th observation come under this. 411 to 530 come under this class. And 531 to 680 come under this class. So we want to find the 340th and 341st. So they will be coming under this class because this class will have the observations starting from 301 to 410. So it is in this class that the 340th as well as the 341st observation fall. And what is the mid value of this class? It is 17.5. So both the observations come under 17.5. So we can directly take the median as 17.5. If suppose the 340th observation was 17.5 and the 341st observation came under 22.5, then we would have been required to add these two and divide it by 2. That means we would have to find their mean. But here both the 340th observation as well as the 341st observation fall under the same class. You can directly take it as the median. So median is the mean of n by 2th observation and n by 2 plus 1th observation, and that is how we came to the answer 17.5. That means we have to take the mid value of that class in which the middlemost observation falls. And since there are two middlemost observations, they are 340 and 341, and both these come under the same class, you can directly take the median as 17.5. If they were under two different classes, then you would have taken their average value. So that is how we calculate median. So it is the middlemost observation. Now we go to the calculation of mode in a continuous series. So here if the series is continuous, that means if it is like 6 to 10, then the next is 10 to 15, then next is 15 to 20, then 20 to 25, 25 to 30, then this column could have been avoided. We could have avoided this column. Whereas here the class intervals are not continuous. That means This class interval starts from 6, ends in 10, and the next one starts in 11, ends in 15. Next starts in 16 and ends in 20. So this is not the class intervals are not continuous, whereas we will go to the previous data where these class intervals were continuous. Then we would have directly gone to the calculation of mode. But here, if you are having a table, tabulated data having class intervals which are not continuous, we have to transform them into a continuous series. That means we have to transform the class limits into class boundaries. So we will just go to the width of each class. What is the width of each class? It starts from 6 and ends in 10. That means the width is 5. Or 11 minus 6 is equal to 5. 16 minus 11 is equal to 5. So that is the width of each class interval. So this is these class intervals are not continuous. If here it would have been 10, it would have been a continuous class interval, but it is not here. So we have to first convert it. So we have to convert it into class boundary. So 6 to 10 is converted to 5.5 to 10.5. 11 to 15 is converted to 10.5 to 15.5. 16 to 20 is converted to 15.5 to 20.5. That means 0.5, the 0.5 which is 6 minus 0.5, and this is 10 plus 0.5. That means the lowest boundary minus 0.5 and the highest boundary plus 0.5. So that is how we made it a continuous series. You can see 15.5 to 20.5, 20.5 to 25.5, 25.5 to 30.5. Now, this discontinuous series has been converted to a continuous series by transforming the class limits into class boundaries. And now we write the frequency. So what is the definition of mode? Mode is that observation which is having the maximum frequency. But here we have to apply a formula when we are finding out the mode for group data. So here we have to apply this formula. We cannot directly take the answer as this. We have to apply the formula, that is mode is calculated using the formula L1 plus Fm minus F1 by 2Fm minus F1 minus F2 into I. So what are these variables? First is L1. L1 is the lower boundary of the model class. So what is model class here? That class which is having the highest frequency is the model class. So in this data, this 10.5 to 15.5 is the model class. So this is the model class. And what is L1? It is the lower boundary of the model class. So model class is 10.5 to 15.5. What is its lower boundary? 10.5. So L1 is equal to 10.5. So L1 represents the lower boundary of the model class. Now, what is I? I is the width of each class. What is the width? 15.5 minus 10.5 is equal to 5. 20.5 minus 15.5 is equal to 5. So the width is 5. Then next is Fm. Fm is the maximum frequency of the model class or frequency of the model class. That means this is the model class 10.5 to 15.5 because it is this frequency which comes the highest, and this frequency is called as the maximum frequency, or it is the frequency of the model class, or the maximum frequency obtained in the study is Fm. Then F1. F1 is the frequency of the class preceding the model class. Which is the model class? 10.5 to 15.5. Which is the class preceding the model class? This one. That means that comes before. That is 5.5 to 10.5 is the class preceding the model class. And what is the frequency? It is 100. So the frequency of this class is 100. Now what is F2? F2 is the frequency of the class following the model class. So this is the class which follows the model class, that is 15.5 to 20.5. What is its frequency? 110. So that is F2. So we will again go to the formula. Mode is equal to L1 plus Fm minus F1 by 2Fm minus F1 minus F2 into I, where L1 is the lower boundary of the model class. Model class is that class which is showing the highest frequency, and this is the model class, that is 10.5 to 15.5, and L1 is 10.5. It is the lower boundary of the model class. Then I is the width, that is 5. 15.5 minus 10.5, 10.5 minus 5.5, that is 5. Okay, so the width is I, the I is the width, or here it is 5. Then Fm is the maximum frequency, that is this one. This is the maximum frequency with which we have found out the model class. So that maximum frequency is 200. F1 is the frequency preceding the model class, that is 100. F2 is the frequency following the model class, that is 110. Now we will apply this formula. Here mode is equal to L1 plus Fm minus F1 by 2Fm minus F1 minus F2 into I. L1 is equal to 10.5. Fm was 200. F1 was 100. It was the frequency preceding 200. Then 2Fm means 2 into 200, that is 400. F1 was 100. F2, that means the frequency following 200, was 110. And I is equal to 5. So that will be equal to 10.5 plus 100. 200 minus 100 is 100. 400 minus 100 minus 110 is equal to 190 into 5. That is equal to 10.5 plus 0.526 into 5. That is equal to 10.5 plus 2.63. And that is equal to 13.13 millimeter. So that is the mode. So in when you take these lengths into consideration, that which has the maximum frequency is 13.13. So the mode is 13.13 millimeter. So this finishes the calculation of mean, median and mode for group data containing class intervals.